Now let's say I wanted to spot CEOs of companies. Now this is a big dictionary lookup, right? Do I have to look at the original document? What do I know about CEOs of companies? Generally. They may not act that way sometimes. So I can spot the CEO.
They're nominally people.
Places, okay, so I've spotted Brussels. Cities, you know, Brussels is a city. Countries, Belgium and the USA. Why? Everyone's been to lovely Brussels, Illinois, right? No? Okay. It's gorgeous. You should really check it out. Here we can start editing the results of other annotators. And this is one place where your simple proper noun spotter might be good enough if you can have a follow-up thing that goes and crosses out the ones that probably aren't right. Here I've got European Union, so I'm going to say probably not the USA. So you can actually disambiguate the results of other annotators without having to change the code for those other annotators. You just have to do cleanups. Writing an exception handler is often easier than rewriting the initial feature generator. Now, why would I do this? If I index everything, then I can ask the question, show me all pages about CEOs in Europe. What would it take typed into a search engine to do that if you hadn't done this? What would the query look like? Someone in the back. If I wanted to find all CEOs in all locations in Europe in a standard search engine.
European CEO list.
You'd need a whole CEO list, right? Could be thousands. And every location in Europe. There are several, I've heard. And then you would have to and this two ginormous ORs, and I can guarantee you they wouldn't run in either your nor my lifetimes. It's a very difficult query for a machine to process. But here's just a two-term Boolean query. So by thinking about what kinds of questions you're going to be asking, running annotators that roll up conceptually the results of it, you can, on very small amounts of hardware, do very complex queries and get results. Okay, so I'm going to talk a little bit about secondary use text engineering. Now that you've sort of heard how we do it, talk about some of the things we do. First off, very basic. You're going to hate this. Always start with the simplest possible way to do it. So let's say dictionary lookup. I have a list of terms and the entities they map to. There are many, many, many problems with this approach, but it's fast. I might be able to get a result out in an afternoon. So let me give you an example of where we actually use this. We looked at SEC filings and we created a list called wiggle words. Wiggle words are things that thesis candidates use all the time with their advisors. Might, hope, could, predict, expect, suggest, often, may, opinion. These are things we're trying to avoid committing ourselves. So we said, what if we just looked at SEC filings, scored the number of wiggle words, and divided it by the length of the filing, and called that a wiggle word score. So we ran it across all of them, and we found something very interesting. Low wiggle word documents tended to be from the lumber and steel industry. These guys have been doing what they're doing for hundreds of years, and they are, we will create 300,000 board feet of this. We will ship 8 million tons of this. Not a lot of ambiguity. The highest wiggle word document was a startup company launching a credit card in China. They had things like, we hope the government will let us go after people who don't pay their credit card bills, but we're not sure they will. I mean, lots of ambiguity. So very, very simple. Took an afternoon, right? Just come up with wiggle words. And now you've got something to score things. And there's actually an interesting result when you pull these up and start playing with them. Could we do better with NLP? Yes, we could do better with NLP. Can I con my boss into letting me spend the time to do better with NLP? Now that I have this, I have some results. I can say, this looks promising, I want to move on. Or I can say there's nothing there, and again move on. So the next sort of class of things is tracking information use. So we found that 5-word groups work pretty well. Does everyone know what shingles are? They're a simple way of saying, show me if they're 4 out of 5 overlap, right, wherever they are, and efficiently tell me if 4 out of these 5 things overlap. So we looked at fractions of paragraph overlap, which seemed to be a very good indicator. Right? You're not going to have 100% overlap between paragraphs, but if 2 paragraphs are 50% identical, that's kind of suggesting there may be some information plagiarism. And it's a good way to find who is implicitly getting information from others. So we did this on blogs to find who is reading other people's blogs. Right? If you start talking about the same topics and using the same clever phrases, you probably got them from someone else if they posted first. If this happens once, it's a coincidence. If it happens 50 times, you're pretty sure what's going on here. So we created a display where here are paragraph by paragraph, and here's document by document, and black means a lot of overlap, and gray means this paragraph has it has a certain amount of overlap. So what is a lot of overlap? So in the original document, we have this phrase. Just the other day, one Republican senator said, and I'm quoting him now, if we're able to stop Obama on this, it will be his Waterloo, it will break him, the president said on Monday. This was from the AP Newsfeed. Our local paper said, just the other day, one Republican senator said, and I'm quoting him now, if we're able to stop Obama on this, it will be his Waterloo, it will break him, the president told reporters. I call this grade school plagiarism. They changed the last 3 words, right? Okay, so now I kind of know where that came from. Now, interestingly, a weak one is last week, Senator Jim DeMint was quoted as telling fellow conservatives, you know, the quote, a reference to the site of French Emperor Napoleon's defeat in 1815. This is more undergrad level plagiarism. We've actually gone and thrown another fact in. But in both cases, you can see where the source of the document was if you've got time dating. We then ran this on federal and state legislation, and we found something very interesting. We found that in many states, certain classes of laws were fundamentally identical. Like, there was the text of a gun law in North Dakota that was very similar to the text of a gun law in South Dakota, that was very similar to the text of a gun law in Minnesota, and we started saying, now wait a second. And so a little poking with people who know this domain said there are lobbies that will contribute to legislators if they will submit legislation that is substantially identical to this sample legislation that they will provide you with. And we were able to track that through all 50 states and find basically who was showing up and getting funding from who to do what. Very interesting, very hard information to get any other way.
The interesting thing is that you did have to step out of the unstructured data idea, right, to get that other complementary information of who was paying whom.
No. All we know is that hypothetically, Senator Amit has submitted a bill that's exactly the same as Senator Mina's in a different state. Our hypothesis is, yes, once
that's fine. Just the part that who was funding it.
Yes, and that was something that we got from a different research group.
So I think the interesting thing is that if you marry the text processing with complementary information, the kind of things we look for in linked data or gov data or so on and so forth, you get a lot more synergies, a lot more interesting insights.
The other thing we found out on federal legislation, it's actually a programming language. I hadn't realized this. There are blocks of code that mean give this agency this much money, but they're about this long and they've been beaten out after 200 years of Congress where everyone agrees that this language means this and it's gone through the courts, so everyone just cuts and pastes this piece of language to mean this. So we're currently sort of trying to reverse engineer the programming language of federal laws because they're kind of a mess in terms of how much they overlap. Okay, so the next thing that's interesting to track is whose are the flows of information. Who's talking to whom and about what? So it's critical for a tool for monitoring illegal information flows as well as legal information flows. And to do so, it's important to look at the sender, the recipient, the content of the communication, and how often they're talking with one another. So basic idea, and this is one that we did with a large financial company. The results I'm showing are from Enron. This person sent email to this person on a particular topic. So you type a topic in, and rather than getting the exact results, you get this grid. Yellows are cases where the information went from inside a financial company to outside a financial company. Right? So these are ones that you might want to look at. And then we did networks of communications, who's talking to who. So this was a slightly embarrassing. We worked with this Fortune 500 company, got all kinds of metrics, talked to their internal investigation groups, what are phrases and words and activities that we should be concerned about, built a scoring algorithm, ran it on Enron, and it failed horribly. Did not work at all. And we were really disappointed, so we went and checked everything, it was all good. Well, it turns out that all of the heuristics for spotting illicit activity made an implicit assumption that not everyone in the company is corrupt. And with Enron, the entire executive suite had no problem sending an email to a mailing list saying, we're doing this illegal thing, right? So all of our heuristics didn't work terribly well. They work great in a normal company, but in Enron they failed kind of